Hey guys, welcome to lesson 9.1 on arithmetic sequences. First, we have the definition of a sequence. A sequence is an ordered set of numbers. The dots or ellipses mean that there are more numbers. A sequence that does not end is called infinite. For example, let's say we have the sequence 3, 5, 7, 9, and so on. I have ellipses, so that tells me, hey, this sequence is going on forever. It's an infinite sequence. Now, we might also notice that there's a pattern for this sequence. The numbers, we're literally just adding 2 each time, all right? To get from 3 to 5, I'm adding 2. 5 to 7, I'm adding 2. 7 to 9, I'm adding 2. So some sequences have a rule to describe the patterns, and in other words, a rule to describe the nth term. The rule for the sequence above is a sub n equals 2n minus 1. And you're like, okay, where are these n's coming from? Well, basically, n is the label for the terms. So for the first 4 terms, n is going to equal 1, 2, 3, and 4, okay? It's essentially the label. Which term are we talking about? So for example, if I wanted to talk about the 100th term of a sequence, n would equal 100. And I could easily plug 100 in for n and figure out what the 100th term is going to be. So n represents the label of the term. The nth term is the general term. Sometimes it's written as k instead of n, so just be aware of that. And the next vocab word I want to talk about is a finite sequence. And a finite sequence is a sequence that has a certain number of terms. The term of a sequence is basically each number in that sequence, okay? So when we're looking at a sequence of numbers, each individual part of the sequence is referred to as a term. The next vocab word is an explicit rule or formula, and this makes reference to a first term. It describes the nth term of a sequence using a number n. So for example, if we had the sequence 2, 4, 6, 8, 10, and this sequence has the rule a sub n equals 2 times n, this is referred to as an explicit rule. I can plug any number in for n, and I can say, all right, well, what's the 100th term of the sequence? I just plug 100 in for n, and then I get the term. So it makes reference to the first term of that sequence. Now, on the other hand, we also have what's called a recursive rule or formula. And the recursive rule or formula, all right, this is going to be like this. So it makes reference to a previous term. So for example, if we had a sub 1 equals 6, and a sub n equals a sub n minus 1 minus 4 for n is greater than 1, this is referring to a recursive rule because we have the term a sub n minus 1. A sub n minus 1 basically means the previous term to whatever term we're referring to in the sequence. And I could easily write recursive rules or formulas. So if I looked at the first sequence of numbers that I wrote down up here, 3, 5, 7, 9, and so on, I could write a recursive formula for this by saying a sub n is going to equal the previous term, a sub n minus 1, plus 2. And what this is telling me is I'm taking each of the previous terms and I'm just adding 2 to it. That's how I get to the next term in the sequence. So that would refer to a recursive rule. All right, so now let's go over examples on how to use these vocab words. So first, we're going to start off with generating a sequence using an explicit formula. Example number 1, a sequence has an explicit formula of a sub n equals 12n plus 3. Find the term a sub 12. Well, if I'm finding a sub 12, I'm really just finding the 12th term of the sequence. So I'm going to plug 12 in for n. So I have 12n plus 3, but instead of n, I'm going to put 12, and I'm adding 3. So I know that 12 times 12 is 144 plus 3. So the 12th term of the sequence is going to be 147. So a sub 12 equals 147. Example number 2, a sequence is given by a sub n equals 4 plus n minus 1 times 5. First, we need to find the first 3 terms, then we need to find the 11th term. Well, if I'm finding the first 3 terms, a sub 1 is going to represent my first term, a sub 2 is going to represent my second term, and a sub 3 represents my third term. So literally, I'm just going to plug 1, 2, and 3 into that formula. So for the first one, I have 4 plus n minus 1, but instead of n, I'm going to put 1. So I have 1 minus 1 times 5. Okay, again, I'm using the formula up above right here. So if I simplify this, I can easily see that 4 plus 1 minus 1, well, 1 minus 1 is going to turn into 0. So we have 0 times 5, that's 0. And a sub 1 is equal to 4. All right, so my first term of the sequence here is 4. Next one, we have a sub 2, so let's plug it in. I have 4 plus 2 minus 1 times 5. Now I know that 2 minus 1 is 1, so I'm going to have 1 times 5, or 4 plus 5, and 4 plus 5 is going to give me the answer of 9. So my second term of the sequence is 9. All right, let's look at the third term. So for the third term, I'm going to plug in 3. I have 4 plus 3 minus 1, and that's multiplied by 5. I know that 3 minus 1 is 2, so that's going to give me 4 plus 2 times 5. Order of operations says we got to do multiplication first, so I have 4 plus 2 times 5 is 10. 4 plus 10 gives me a final answer of 14. So my third term is equal to 14. So if I were to write out the sequence in the first three numbers, my first three numbers would look like 4, 9, 14, and so on, all right? We just keep going from there. So this is my answer. All right, now I need to find the 11th term of the sequence. Well, if I'm finding the 11th term, I'm just finding what is a sub 11. So I'm going to plug 11 in for n. So that is 4 plus, instead of n, I'm going to put 11 minus 1 times 5. All right, well, I have 11 minus 1. That's going to give me 10. So I have 4 plus 10 times 5. Order of operations says do multiplication first. So I have 4 plus 10 times 5 is 50. 4 plus 50 gives me 54. So the 11th term of the sequence is going to give me 54. So a sub 11 equals 54. All right, let's go ahead and move on to the next page. On to the next page, now we have example number 3. The numbers in the sequences below follow a general pattern. Can you write the general rule? Part A, we have 6, 16, 26, 36, and so on. Now, what I would do in class is I would typically allow you to struggle for a little bit. I would watch you try to find the formula. Some of you guys might find it right away. Some of you guys might struggle. There might be some tears. There might be some, fighting, whatever. But I'm going to spare you the trouble this year because we are online, and I will teach you how to write the formula right off the bat. So here's the deal. We always want to look and see what's the pattern. To get from the first term of the sequence to the second term, look and see how I have to add 10, right? So to get from 6 to 16, I'm adding 10. Then to get from 16 to 26, I'm adding 10 again. Oh, would you look at that? To get from 26 to 36, I'm adding 10 again. Every single time I go from one term to the next, I am adding 10 to the previous term, and that is the rule. So how do I write that down in algebraic form? Well, I know that D is equal to 10. D represents my common difference, okay? It's the number that I'm adding each and every time to get to the next term in the sequence. So D represents the common difference. Now, if I know what the common difference is, I'm going to follow this formula to figure out what the rule of a sequence is going to be. And the rule is as follows. A sub n is equal to A sub 1 plus n minus 1 times D. So let's go ahead and talk about what each of these parts represents right here. I'm actually going to move this over just a teeny bit. Perfect. Okay, so A sub n, that is referring to the term that we are trying to find, right? So if I'm finding A sub 7, for example, that means I want to find the 7th term of the sequence. A sub 1, that represents the first term of your sequence because the subscript is 1, all right? And we know that n represents the label of the term, okay? So A sub 1 is your first term. N is going to be the thing we plug into depending on which term we're trying to find. And D, that is your common difference. We just found what the common difference of part A is, so I'm literally going to take this common difference, plug it in for D. So the rule of this sequence is going to be A sub n is equal to my first term. My first term here is 6, so I have 6 plus n minus 1 times D. Again, D is the common difference, which in our case here is 10. So now I just need to simplify it, and then I'm going to put my final answer in most simple form. So multiply the 10 to both terms inside the parentheses, and we're going to get 6 plus 10 times n is 10n. 10 times negative 1 is negative 10. Last but not least, let's combine like terms. I have positive 6 and negative 10. That's going to give me 10n minus 4. So A sub n is equal to 10n minus 4. That means I could plug any number in for n and figure out what any term in my sequence is equal to. Part B, we have 1, 1.25, 1.5, 1.75. Let's go ahead and look at the pattern. Each time I'm going from one term to the next. Look and see how I'm adding 0.25. Okay, so every single time I'm adding 0.25. So my common difference, D, is going to be equal to 0.25. So same thing, I'm going to plug it into the formula. I have A sub n equals A sub 1 plus n minus 1 times D. So let's go ahead and do it. A sub n equals my first term, which is 1, plus n minus 1 times my common difference D, which is 0.25. So let's take 0.25, we're going to distribute it into the parentheses, and we get 1 plus 0.25n minus 0.25. Last step is just to combine like terms. I have positive 1 and negative 0.25, so my final answer is 0.25n plus 1 minus 0.25, that's 0.75. So A sub n is equal to 0.25n plus 0.75. That is the rule I'm going to use. Last but not least, we have part C, negative 1, negative 4, negative 7, negative 10, negative 13. These numbers are getting more negative, so common differences can also be negative numbers. To get from negative 1 to negative 3, I am subtracting 3. From negative 4 to negative 7, subtracting 3. Each and every time I'm subtracting 3, so my common difference is going to equal negative 3. Same thing, just plug it into the formula. We get A sub n equals A sub 1, which is negative 1, plus n minus 1 times the common difference, negative 3. Let's take that negative 3, distribute it inside of the parentheses, and we get A sub n equals negative 1 plus, that's going to be negative 3 times n, so that's actually negative 3n. Negative 3 times negative 1, that's going to give me positive 3. All right, combine like terms, and we get the rule A sub n is equal to negative 3n, and then we have negative 1 plus 3, that gives me positive 2. So this is the rule of the sequence. Now moving down to the next segment of the notes, which talks about recursive definitions for a sequence. We touched on this a little bit on the previous page, but now we're going to go into some more detail. So the recursive formula definition says that recursive sequences contain two separate parts. The first part is the initial condition, or in other words, the value of the first term, A sub 1. And the second part is the recursive formula, which is the formula A sub n equals A sub n minus 1 plus D for all n is greater than 1. Now, just to point out, we talked about this on the previous page, but A sub n minus 1 essentially represents the term before A sub n. So if we're trying to find what A sub n is equal to, we just need to identify what the previous term was in the sequence, and then we could easily plug it in and use the common difference to find what A sub n equals. So example number 4, look for simple addition or subtraction patterns to relate consecutive terms. Then write a recursive rule for the sequence. Well, part A, we have the sequence 1, 4, 7, 10, 13, and so on. The first thing that I want to do is I want to identify what my pattern is. So what's happening from one term to the next term in the sequence? Well, let's take a look at my numbers. So to get from 1 to 4, it looks like I'm adding 3. Then to get from 4 to 7, again, it looks like I'm adding 3. 7 to 10, I add 3 again. And 10 to 13, once again, I'm adding 3. So since I'm adding 3 each time, my common difference D is equal to 3. And this is great because I know that I need to know what D equals in order to write the formula for the recursive formula. All right, so if I need to write the pattern or the rule for this sequence, again, I need two different parts for the recursive rule. I need the initial condition and the recursive formula. So this answer is going to be broken up into two separate parts. The first part, I need to identify what A sub 1 is equal to. And I know that A sub 1 is going to be my first term of the sequence, all right? N just represents the label of the term, essentially. So A sub 1, the first term is equal to 1, and my rule is going to simply be A sub n is equal to A sub n minus 1. I'm not going to plug anything in there because this is, again, the rule. I'm not writing any specific number here. And I'm just going to add the common difference, which I know is 3. So the recursive rule for this sequence is going to be A sub 1 equals 1, and then A sub n equals A sub n minus 1 plus 3. And that's it. I'm done. Moving on to part B, I have 4, negative 1, negative 6, negative 11, and negative 16. Well, once again, I need to figure out what my pattern is. So to get from 4 to negative 1, well, it looks like I'm subtracting 5. To get from -1 to -6, once again, I'm subtracting 5. -6 to -11, I subtract 5. And then -11 to -16, I'm subtracting 5. So my common difference D is equal to -5. I'm subtracting 5 each and every time I get to the next term in the sequence. So now if I'm going to write my rule, I'm going to break this into two parts. First part is a sub 1, or my first term. That happens to be 4 here, so a sub 1 equals 4. And then the recursive rule. A sub n is equal to a sub n minus 1, or the previous term, minus 5. And this is the recursive rule for the sequence. All right, moving on to the next page. Okay, so now that I've talked to you all about sequences, now I'm finally going to assign a name to the types of sequences that we've been looking at so far. And the type of sequences that we've been looking at are referred to as arithmetic sequences. And what this is a sequence that has the same differences between terms. So we have D equals a sub 2 minus a sub 1, or a sub 3 minus a sub 2, and so on. And what this is saying is that an arithmetic sequence is any sequence where no matter what term you're taking from the entire sequence, if you were to subtract the previous term, you should be getting the same number every single time. So if I take the 47th term and I subtract the 46th term, I should be getting the same value as if I took the second term and I subtracted the first term. It means that we have a common difference. And so D represents the common difference between the consecutive terms. And we've already touched on this just a little bit. Now, each term in an arithmetic sequence can be obtained recursively from its previous term by adding D. And we know that because all we have to do is take the previous term and add some number, and that means we're looking at an arithmetic sequence. Now, there are two different forms of the way that you can express arithmetic sequences. You can express them using explicit or general form, and the common formula that we're going to use is the formula a sub n equals a sub 1 plus n minus 1 times d. Now, just a heads up, this is the formula that you will have to remember because this is the formula that we commonly see when we are referring to arithmetic sequences. And again, this is for all values of n that are greater than or equal to 1. We also have the formulas a sub n equals dn plus c, and c equals a sub 1 minus d. But again, we will be using that common formula that we see above in the highlighted portion. All right, and we can also use the recursion formulas, which we touched on a little bit already. But what this says is a sub 1 equals whatever your first term equals. That's the first part of the recursive formula. And then we have the formula a sub n plus 1 equals a sub n plus d. On the previous page, you saw it expressed a little bit differently. We had it written as a sub n equals a sub n minus 1 plus d. Same exact thing, right? The only thing here is we're saying, all right, well, the next term in our sequence is going to be whatever the current term is plus the common difference. And again, all values of n that are greater than or equal to 1. And we do see the formula that we saw on the previous page written down below. These are both the recursion formulas for arithmetic sequences. All right, let's move down to the next part, which says analyzing arithmetic sequences. Example number 5. Is the sequence an arithmetic sequence? We have the numbers 1, 5, 9, 13, 17, and so on. Well, let's go ahead and look at the pattern. First things first, I want to see what I'm adding or subtracting to get to the next term. Well, to get from 1 to 5, it looks like I'm adding 4. To get from 5 to 9, I'm adding 4. 9 to 13, I'm adding 4. And again, I'm adding 4. So since I'm adding 4 each and every time, I'm going to say, yes, I have a common difference. I'm going to say I have a common difference of 4. All right? So that's the number I'm adding each time to get to the next term in the sequence. And I'm going to take you one step farther. So yes, this is a sequence that is arithmetic because we do have a common difference. But let's say I wanted to write the rule of the arithmetic sequence. Well, there's a couple of different formulas that we have listed above. Let's look at the easier formula first. I have the formula a sub n equals dn plus c, when c equals a sub 1 minus d. So let's go ahead and figure out what c is equal to. So if c equals a sub 1 minus d, well, I know in our case here that a sub 1, and I can label this to the right here, I know that a sub 1 is equal to my first term, 1, and d equals my common difference, which is 4. So if I'm finding c equals a sub 1 minus d, all I'm going to do is plug in 1 for a sub 1 and 4 for d. So I find that c equals -3. So then all I have to do is plug it into the formula. A sub n equals dn plus c, which is the first formula I saw written in that second box of the table here. Okay, so let's plug it in. So I have a sub n equals dn plus c. So that means a sub n is going to equal the common difference, which is 4 times n plus c, and I know that c is negative 3. So a sub n is equal to 4n minus 3. And this is the rule that I'm going to use for the arithmetic sequence. So that's the first way we could do it. We could use the formulas that were written down below, right here in the second box. But we could also use that formula that I highlighted. And this is actually the formula that I would recommend using every single time. So the original formula that you typically see when we're referring to arithmetic sequences is a sub n equals a sub 1 plus n minus 1 times d. Well, now this is pretty easy because I already know what a sub 1 and d are equal to, and the rest I'm just going to leave alone. So a sub 1 is equal to 1, so I say a sub n equals 1 plus n minus 1 times d. I know that d equals 4, so I'm going to plug it in. All right, so now all I have to do is I have to distribute this 4 to both terms inside the parentheses, and I get a sub n equals 1 plus 4 times n, and then 4 times negative 1 is negative 4. Then, if I combine like terms, I find that a sub n is equal to 4n, and then I have 1 plus negative 4, that gives me negative 3. So as you can see, we get the same rule no matter which method we use. I would prefer that you use the second formula because that's the one you commonly see. All right, example number 6. We have find the 46th term of the sequence 2, 5, 8, 11, 14, and so on. Okay, so now we need to use what we know about writing the rule of a sequence in order to find a specific term. Specifically, we want to look at the 46th term. So what we have to do first is we have to identify the common difference, the first term, then we have to write the rule of the sequence, and after we write the rule of the sequence, then we can find the 46th term. So first things first, let's figure out what the rule of the sequence is equal to. Well, in order to write the rule, let's find the common difference. To get from 2 to 5, I have to add 3. To get from 5 to 8, I have to add 3, and so on. I keep on adding 3, so I can clearly see that my common difference is equal to 3. I also know that a sub 1, my first term, is equal to 2. And those are the two things I need to know in order to write the formula. So let's go ahead and use this formula right here. We have a sub n equals a sub 1 plus n minus 1 times d. Let's plug some stuff in. So I'm going to have a sub n is equal to, instead of a sub 1, I put 2 plus n minus 1 times the common difference 3. Now let's simplify it. All I have to do is distribute this 3 to both terms inside the parentheses, and I get a sub n is equal to 2 plus 3 times n, and then 3 times negative 1 is negative 3. All I have to do from this point forward is combine like terms. So a sub n, the rule of the arithmetic sequence, is 3n, and then 2 minus 3 gives us negative 1. So this is the rule I'm going to use. Now, if I want to find the 46th term, all I'm going to do is I'm going to figure out what a sub 46 is equal to. Or in other words, I'm just plugging 46 in for n. So I have 3 times n, but instead of n, I put 46. So 3 times 46 minus 1. Now, if I simplify that a little bit, I know that 3 times 46 is going to give me 138 minus 1. So I find that a sub 46, the 46th term of the sequence, is going to be 137. And those are my answers to example number 6. Now on to the last page of the notes for today. We have example number 7. Find the missing numbers in the sequence 80 blank blank 125. All right, so in order to find the missing numbers, I'm going to have to use the two numbers that I already know. I have 80 and 125. Now, if this truly represents an arithmetic sequence, here's what has to happen. We have to have some number that we are adding 1, 2, 3 times to give us 125. So what we can do is we can figure out how much had to be added to 80 in order to get us to 125, and then we could divide that by 3 separate instances of having to add the common difference, and then we will know what our common difference is equal to. So let's take that last number, 125, and we're going to subtract the first number, 80. And that difference is going to give us an answer of 45. So I know that from 80 to 125, I have added a total of 45. Obviously, I have to do 3 separate addition problems here to get each individual term. So let's take that 45 and we're going to divide it by 3. 45 divided by 3 gives me 15, so I find that my common difference D is equal to 15. And let's go ahead and fill in the blanks here. So I start with 80, and if I add 15 to 80, my next term is going to be 95, so that's one of the missing values. And then if I add 15 to 95, I'm going to get 110. That's the next missing value. And then if I add 15 to 110, I get 125. So yep, that means I did it correctly. My missing values are 95 and 110. All right, so last couple of examples. Going down to example number 8, we are going to use the explicit formula for an arithmetic sequence. The number of seats in the first 16 rows of an arena form an arithmetic sequence. If there are 20 seats in row 1, 23 seats in row 2, how many seats are in row 16? Okay, so although this is a word problem, like we said, this follows an arithmetic sequence. So we can easily write the rule of the arithmetic sequence and then plug in 16 to figure out what the 16th row is going to look like. So in order to write an arithmetic sequence formula, we need to know 2 things. We need to know what the first term is, and we also need to know what the common difference is. Well, I know if there are 20 seats in row 1, my first row has 20, my a sub 1 or initial value is 20. My common difference, well, from row 1 to row 2, all I did was I went from 20 seats to 23 seats, so my common difference is 3. I'm adding 3 every single time. We know that the formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times the common difference d. So all I have to do is plug in a sub 1 and d. So I get a sub n is equal to 20 plus n minus 1 times the common difference, d. So now, I'm just going to simplify. Distribute the 3 into both terms inside the parentheses. We have a sub n equals 20 plus 3n minus 3. Combine like terms, I have positive 20 and negative 3. I get a sub n equals 3n plus 17. So now that I found my rule, I have to figure out what the 16th row looks like. Or in other words, I'm going to find a sub 16. So let's plug 16 into that formula we just created. We have 3 times n. Instead of n, I put 16 plus 17. All right. Well, if I figure out what 3 times 16 is, 3 times 16, that's going to give me 48. So I have 48 plus 17. And then I know that 48 plus 17 is going to give me a final answer of 65. So I have found that there are 65 seats in row 16. And that is my final answer. All right. Last example for today, example number 9, we are using the arithmetic mean. So find the missing term of the arithmetic sequence. We have 132, blank, and 98. And this is one of those rules that we can use. All right, well, if we have a missing term in the middle of the sequence, I obviously don't know what a sub 1 is equal to. I don't know what d is equal to, but I can easily use the idea of the mean or the average to figure out what the term between those 2 terms is going to be. So again, mean is really a synonym for average. Okay, so I'm just going to find the average of the terms. So let's go ahead and take these 2 terms, 132 and 98. We're going to add them together, and we're going to find the average. So 132 plus 98, if we're taking the average of 2 numbers, that means we're dividing by 2. So we know that 132 plus 98, that gives us 230 over 2. And then 230 over 2, that gives me 115. So the missing term of the sequence here is the term 115. All right, guys, and that is lesson 9.1 in a nutshell. Thank you for tuning in, and go ahead and make sure you log in and do your assignment. Let us know if you have any questions. All right, guys, I'll see you back here next time. Thank you.